In this class, we are discussing about the dual nature of radiation and matter. So, in this radiation and also the matter means that is a particle is a material object that can be, we are considering about the tiny level of the matter. So, that is called the particle. So, and also the radiation, the electromagnetic radiations are considered as a waves. So, that is also gives the, that is exhibits the wave nature, and it also obeys the interference, diffraction and also polarization. So, this is the wave, that is the radiation of the electromagnetic. But in this lesson, we are discussing about the two natures of the particles, that is the particle nature of waves, that is radiation, and also the wave nature of particles, that is matter. So we are discussing the dual nature of this wave particle. So that is the discussion about this lesson. First topic, electron emission. So the electron emission means the electrons which can be present in the metals, the outermost shells are loosely bound, that is it can be present in the, that is outer layer of the nucleus. So it can be loosely bounded to the nucleus. So even at the room temperature, so the free electrons are not able to come out of this metal. So that is the moving inside the metal only, that is called the free electrons. So for giving any extra energy for that, that is we are raising the temperature like that. So the electrons are possible to come out the surface of the metal. So that electrons are, that phenomenon is called the electron emission. But on before that, the potential barrier which prevents the free electrons from leaving the metallic surface is called the surface barrier. That is, that metals cannot allow the electrons to come out. So that is called the surface barrier. So before that, when the electrons are come out of this metals, the potential barrier, it is one of the barrier that can be present at the surface of the metal. So that can be prevents the free electrons from living out of that metallic surface. That is called the surface barrier or potential barrier. So when the electrons are come out from the surface, so that is considered as the electron emission. So that is called the surface barrier or potential barrier. And next to that, the liberation of the electrons from any surface of the substance is called electron emission. So that is called the come out of the electrons from the surface. So it can be break out the surface barrier or potential barrier. So because of we are giving the external energy for that, so that can be, electron can be emitted. So that is called the electron emission. So when we are giving the external energy, so what happens in this electron means it can be producing some energy. So that minimum energy for escaping this electron from the metal, that is called the work function of that metal. So here generally considered as the work function means the kinetic energy can be produced at the electrons. So that is called the work function of the metal. The work function can be denoted as a letter phi naught. So and also it can be measured in electron volt. So that is called EV. So generally the SI unit of energy is volt, that is not a volt, a joule. The SI unit of energy is joule because work done and energy having the same unit. So here we have to measure 1 electrovolt is equal to kinetic energy gained by the electrons, that is work done by the electric field. What is the work done formula? Generally potential difference V is equal to W by Q. So here W is equal to Q into V. So Q means charge of the electron, that is 1.602 into 10 to the power minus 19 coulomb, and also for 1 volt, that is 1 volt, that can be represented as again 1.602 into 10 to the power minus 19 joule here. So that is the 1 electron volt unit. So here the tabular column is given. Different element have the different energies to come out the electrons. So that is also having a different function, that is work function. So here some of the metals that work function is also given, and go through this tabular column. So the next topic is types of emission of electrons. So in this first type, thermionic emission. So here the thermionic emission means when metal is heated with a high temperature, the free electrons can be removed, that is escaped on the surface of the metal. So it also gets sufficient amount of energy in the form of thermal energy. So this type of emission is called thermionic emission here. So here the metal is given, and also the electrons are present as a hole-like structure. So here the thermal energy is given, so that is below. Using the lamp, the electrons can be liberated. And the second one is field emission. So in this field emission, electric field is present, so that can be represented as positive and negative. Two electrodes are present. In between that, we have to put one of the metal. So what happens, the electrons is also emitted. So this is a strong electric field when the electrons are also ejected out. So this type of emitted of electrons is considered as a field emission. And the third one is photoelectric emission. In this photoelectric emission, when an electromagnetic radiation with a suitable frequency that can be incident on the metal, surface of the metal, so what happens, the energy is transferred from radiation. So that is in the form of a free electrons. So that free electrons get a sufficient energy, so that can be cross over the surface barrier. So that is called the photoelectric emission. So this number of electrons emitted, that can be depends upon the intensity of the radiant, that is incident radiation. So this type of emission of electrons is called photoelectric emission. Simply we have to say that when the photo means light, when the light radiations is passed through the metals, so it can be ejected the electrons. So that is called the photoelectric emission. So on the last one is the secondary emission of electrons. So this is nothing but when the high speed electrons can be heated through the some metals, that free electrons can be come out. So that type of electrons is called the secondary electrons here. So these are all the four types of emission of electrons. So the next topic is photoelectric effect. In this photoelectric effect means the ejection of electrons from the metal plate, so by light. So that is called the photoelectric effect, or maybe we have to use other electromagnetic radiation also. So with the suitable wavelength, that is called photoelectric effect here. So that can be explained by the two experiments, that is observations, Hertz Hallworks and Lenard's observation. So first we have to discussing about the Hertz observation. So this Hertz observation, we are already discussing about this observation. So that is, it was the electromagnetic waves can be produced by detected by a detector, that is a copper wire bent in a shape of a circle. So the detection of wave is like a spark produced in the detector. So that is called the Hertz experiment. Here the diagram is not given in your book, so but this is a just as a detector. So by this detector, the spark of light can be produced in the detector. So this is the, so by this experiment he noticed that the spark, the Hertz made many attempts, that can be finally he noticed that the detector spark became more vigorous when he was exposed to the ultraviolet light on that. So next he has improved that experiment and also forms a more vigorous amount of that spark of light is produced. So here whenever he used the ultraviolet rays is also incident on the metallic sphere, the electrons on the outer surface are emitted. So that's he conclude that the photoelectric emission, because of the electrons can be come out, the spark is produced because of this photoelectric emission. So that is the experiment, that is Hertz experiment, that is also we are discussing in the fifth lesson. So the next experiment is Hallworks observation. In this Hallworks observation, he is a German physicist. He concluded that A strange behavior of a spark is due to the action of the ultraviolet light. So that can be made by the simple experiment here. So he had to take a circular plate of zinc that can be molded on a insulating stand, and it can be attached, that is inside this insulator stand it can be attached to the gold leaf, so that is electroscope by a wire. So when the uncharged zinc plate is irradiated by the the ultraviolet light can be passed through on that zinc plate. So what happens, it becomes the positively charged and the leaves will open as shown in this figure. That is, the A figure shows that the leaves will open because of this, the radiations which can be passed on the zinc plate. So it is not a charged plate. And next one, the B picture shows that if it can be the negatively charged zinc, the zinc plate is charged to the negatively plate, it can be exposed to the ultraviolet light. What happens means the leaves come closer to each other, so very quickly. So because of the charge of the zinc plate. And also if the charge is, and the third picture, if the charge is replaced, that is if the plate is positively charged, what happens means it becomes more positive because of UV rays irradiation on the surface of this zinc. So the leaves will also further open. So from this observation, he concluded that the negatively charged electrons are emitted from the zinc plate under the action of the ultraviolet light, because the third picture clearly shows that the electrons can be ejected out. And the two pictures is also, that is A and B is also, the electrons can be ejected out. So because when the zinc is uncharged and it also charged at a positive and also the negative, the electrons gets ejected out. So this is the hallmark observation. So and the third experiment is Leonard's observation. In this Leonard's observation, this is the experimental setup of the Leonard's experiment, that is observation. So in this observation, the cathode and anodes are connected to the battery. So with some potential difference, the current can be passes through from anode side. And what happens, the ultraviolet radiation is also passed through that cathode side. So what happens, the electrons can be ejected out from the cathode to the anode region. That can be denoted in the galvanometer. The deflections can be shown in the galvanometer. So this type of experiment shows the Leonard observation. So what is the conclusion for this experiment means, thus the electromagnetic waves of one of the wave, that is the ultraviolet light falling on the negative plate, causes the electron emission from the surface of the plate. So this is the observation for this Leonard observation.